We're learning starting Unit 5. Everybody, Chapter 5, Unit 5. If you ever want to see where we're going over here, you can look on that poster by Ben. And Unit 5 is right in the middle. It goes up to 10. And 5 is about classes. And this is stuff that we did before. We did some of this in Unit 1 and 2. So it should we're like circling around and you should be like, oh, I get it now, or it should be a little better than it was. So classes 5.1. A class is a blueprint of a real world object. Objects have attributes, which we store in variables, and behavior, which we define using methods. And you create objects using the new keyword. So this is an example. Scanner scan equals new scanner system.in. So that creates an object named scan, and it's the class of that object is scanner, and scan, the variable or object, is an instance of the scanner class. You need to know these terms. So class is a recipe or a blueprint for a particular type of object. Think about apple pie. You have a recipe for an apple pie. You don't eat the recipe, hopefully. You use it to make pies, and you can make either one pie or 100 pies with a single recipe. So the recipe in our case is the class, and the pies are the objects. And I'm going to show you a short video if this link still works. Yep, here we go. Thanks, lady. I don't know who she is or where I got that video, but thank you, YouTube. Everybody, a class is declared like this. You say class rectangle, or you might often see it public class rectangle. If you use public, then the file that the class is stored in has to be called that name with Java at the end. So, and this doesn't always work for us in REPL because we're in a class called main. And then lots of times, like when I've given you frog assignments, the frog class is just sitting down below the main method. I mean, the main class. And I have class frog. In that case, it can't be public class frog because it has to be in its own file all by itself if it's a public class. And before, when I used to have people do their work on the computer, we named everything public class whatever because that's just normally how you do it. But when you're doing it online in REPL, it's just it's fine. We leave the public off of that one. Class names start with a capital letter. That's just Java convention. It'll work if you don't do that, but that's what I'm going to ask you to do. And then the body of the code in the class is in between a pair of curly brackets, braces. So inside a class up at the top, we define the variables, which she called attributes or instance variables. Variables must always be declared as private. And we'll discuss that more later this week. But here's an example. If I made a class rectangle, I might have an integer for the width and an integer for the height. And this is how you would declare them. So private int width, private int height. Variables are called attributes or instance variables or just variables, or one of the people the College Board has giving the notes on our little videos she calls them data members. Like, I don't know why you're not just calling them variables or instance variables, but they give the objects their differences. Like in that video, the two dogs were different colored, so that would have been in a variable. Next, a class typically has one or more constructors. These initialize, set up, and fill out the attribute information, getting an object ready to be used. So this is an example of a constructor. Constructors always have the same name as the class, and they have to be public. So this is a constructor, public rectangle. It's always just that, just the word public and then the name of the class. That tells Java, hey, this is the constructor. And in this case, I made the constructor accept two variables, a W and an H, that are both integers, and then it sets the width and the height to those variables. So notice there's no return type. It doesn't say public void rectangle or public string rectangle. Classic constructors don't have return types. It's just the word public and constructor. They don't return anything to anyone. Any questions? Classes can have methods which define their behavior. So, and you've seen this before, so I'm using this rectangle example. A rectangle, you might be able to ask a rectangle, hey, what's your area? And then it can return it for you. So this one does have a return method. It says public int get area. That says, hey, if you call this method, you're going to get an integer back, and in fact, it's going to return the width times the height, which is the area. Most of the time, you make your methods public. It's possible to make private methods that only the internals of your class can use, but that's pretty rare. Methods have a return type, string, double, Boolean, void. You know, all those, every single one of those coding problems, those all had a return type. You had to look and see, what are they asking for? They asked me to return a string, or they want me to return true or false, or an integer. And that's what we're talking about. This one has the return type is always right before the name. So public int get area means it's going to return the area as an integer. And then you have to store that in a variable or print it or do whatever you want with it. But another example, public void set width. This is a method I made that changes the width variable. So it's like, what if you created a rectangle and then you either made it smaller or you had created it with the wrong width? You might call this method to make the width shorter. So this is a void method. It doesn't return anything because you're sending information to the rectangle object like, hey, I want you to have a new width. Here you go. It wouldn't seem to need to send any information back. So calling this method just does what it does and doesn't print or return anything. Any questions? Some classes have a toString method, and a toString method returns a string representation of the class. So a piece of text that whoever wrote the class says, this is what I want my class to look like if somebody prints it. So if you don't write a toString for a custom class, then when you print it, you get something like, look at what I have over here, frog at 6ff3, blah, blah, blah. You get something like that. It says the name of the class and then an @ symbol, and then this is like a memory location. So that's a way for Java to keep track of it. But when we print a frog, I think it's much more satisfying to have like the number of spaces it's hopped and then the little symbol. And that's because my frog class has a toString method in it. And If you don't have a two-string method, you're going to get something like this thing that just is, useless. It does tell you printed the class, but this is the frog two-string code. Now that you can understand it, I've never walked you through it, but now that we know for loops, you can understand it. I create an empty string, and I do a for loop from 0 to I less than location, and I add a period for every location the frog is hopped. Temp plus equals period. So if it hopped 10 spaces, I would be 0 through 9, which is 10 numbers, and that'd be 10 periods. And then I return that string plus the @ symbol. That's just, you're going to be writing two strings from now on all your custom classes. So today, in a minute, we're going to write a custom class from the ground up together for a person. But first, I want to show you some custom classes we've used in our class so far. So I'm opening up a REPL, and you'll have a copy of this shortly. So check this out. I'm in right here. It says main.java. So over here on the left, you can find it, main.java. And this starts with, it's pretty much mostly empty. It says book class, review the book class to the left, and right here, create and print two book objects, and then do the same thing for the circle class, the frog class, the rectangle class. And then we're going to go to the person class and write a whole new class. So if I run this right now, it's just going to print these little headers without any information, but I'm asking you to make one of each of these things and print it. So right now it just says book class, circle class, frog class, rectangle class, person class. But let's take a look at the ones we've done already. So we've done a book class before. You got to look at book.java. If you look at book.class, this is like the compiled code. So that looks like garbage. We're going to look at book.java. And this is a class that you've used before. I forget if it was unit 2 or unit 3. Public class book, private string title, private string author, private int year. So a book has a title, an author, and the year it was published. And here's a constructor. Here's another constructor that creates a book if you just know the title but you don't know the author. Here's another constructor that creates a book even if you don't know the title or the author or the year it was written. And then here's a two-string that prints out the book. Looking at the circle class, you may remember this. A circle just has one attribute, the radius in this world. And you create it by sending over the radius as a double variable. And you can get the area or the perimeter, which is 2 pi r, the circumference. The frog class, we've looked at a lot. Then the rectangle class we just looked at, but here it is all in one place. And then finally, the person class is empty, and it has instructions here on what I want you to put in it. And I'll assign this right now. So I'd like you to go and do the other classes before you get to the person class. And I think, well, we'll see. I have another class on deck if I need to assign another thing. We'll see how long this takes us all. I'll stop the recording.